All right. It's time for another screencast in AP Psychology. In this screencast, we're going to look at how and why psychologists do research. So let's investigate what this screencast has to offer. First is hindsight bias, also known as I knew it all along bias, but I bet you knew that already. Hindsight bias is the tendency to believe after learning an outcome that one would have foreseen it or they knew it all along. Now, take the time to read these and see what you think. Pick true or false and hit pause now because I'm going to move on in just a second. Now that you knew the answers, did it feel like you knew them all along? We often think we know more than we do. When you're wondering how sure you are of yourself, most people are pretty confident that they are correct. Humans tend to overpredict how often they are right, and even when they're wrong, they use the term, well, I was close enough. Example, Richard Goranson studied how long do you think an average person took to unscramble these words here? If you were to look at them, you probably guess 10, 20, maybe 30 seconds. When the reality is it's closer to 3 minutes. Once you're given the answer, it's much, much easier. Our brains are predisposed to find patterns. Something may be familiar, like a face in the moon or an image in a random chip. We want order in our lives. So our brains perceive order. They can perceive order in normal tasks, such as randomly flipping coins. We want to see patterns. So, what are the odds of getting a royal flush on the left or random cards on the right? Reality is, you have an equal chance of getting the cards on the right as you do on the left. Now let's look at the scientific method. First up is theory. A theory is an explanation using an integrated set of principles that organizes observations and predicts behaviors. A hypothesis is a testable prediction, often applied by a theory. The key here is that the hypothesis is testable. An operational definition is a carefully worded statement of the exact procedures used in a research study. Replication is repeating the essence of a research study, usually with different participants in different situations, to see whether the basic finding extends to other participants and circumstances. But for this slide, I want to focus on operational definition. Operational definitions are vital to researchers. It defines what the researcher will be observing, and manipulating operational definitions need to be measurable and manageable. Remember, all good research can be replicated. Here's some info on what a good theory is, and I'll let you read it as opposed to reading it to you. A case study is a descriptive technique in which one individual or group is studied in depth in hope of revealing a universal principle or a truth applied to a generally larger population. Much of the early knowledge about the brain has come from case studies of individuals who suffered a particular impairment after damage to a certain region of the brain. We then can use the information we found and apply it to everyone's brain. Now, this is very useful. However, because it is limited in size to maybe one individual, it is atypical and could have skewed results. Next descriptive method is a naturalistic observation. This is observing and recording behavior and naturally occurring situations without trying to manipulate and control the situation. This can't be unobtrusively videotaping parent-child interactions from different cultures. It could be watching chimpanzees in their natural habitat. It doesn't explain the behavior, it just describes what is happening. Next up is the survey. The survey looks at many cases in less depth. It is a technique for ascertaining the self-reported attitudes or behaviors of a particular group, usually by questioning a representative random sample of the group. The way we frame a question can skew our results. In a survey, for example, using the word aid to the needy as opposed to welfare can lead to very, very different results in the data. Sampling bias is a flawed sampling process that produces an unrepresentative sample. A random sampling is a sample that fairly represents a population because each member has an equal chance of inclusion. So if I were to go try to send a survey out to the school, but only picked certain classes, I wouldn't have a true representation of the entire school. If the classes were randomly sampled, then I could probably get rid of some confounding variables just by using the random sampling. Now let's get into data. A correlation is a measure of the extent to which two variables change together and thus of how well either variable predicts the other. A correlational coefficient is a statistical index of the relationship between two variables, usually from -1 all the way to 1. We can represent this using a scatter plot. A scatter plot is a graph of cluster of dots, each of which represents the values of two variables, which gets us into slopes, which I know you're very familiar with. So here is a scatter plot with a positive correlation. This one has no relationship. Here's a perfect positive correlation and a perfect negative correlation. Now, correlation helps us predict. It does not answer why. For example, gun ownership helps predict increase in homicide. And of course, we can get into this into a lot of different details. But could it be that more people are buying guns that live in dangerous places, thus correlating homicide? Or could we look at a negative correlation where, let's say, low self-esteem correlates negatively with depression? But the question is, does self-esteem cause depression, or do you get depressed after having low self-esteem? The answer isn't as cut and dry, but there is a correlation. Illusory correlation is one that perceives a correlation where none actually exist. For example, let's say you go eat at Taco Bell and less than 30 minutes later you're already sick. You're going to assume that Taco Bell caused it. The reality is your body actually needs more time to react to certain foods. So more than likely, you're probably getting sick from what you ate from the meal before. The experimental method is extremely important because it's the only way to find what's called a causal relationship, which is a fancy way of saying one thing causes another. This is where we need to have controlled experiments, where we can isolate the independent variable. In psychology, it is not always possible to control everything, so having as few outside factors affecting the independent variable is very important. The point of any experiment is to manipulate a variable to determine its effect. In a good experiment, we are going to have the experimental group receive the independent variable, but we also have a control group that does not. This allows us to look at the data to determine how effective or ineffective the independent variable was. When conducting an experiment, it is important to make sure your sample size includes random assignments of who gets the independent variable and who doesn't. This eliminates any reason other than the independent variable in the experiment. Have you ever had a cold and took a sworn by remedy from grandma and the cold got better? Sometimes it's just timing. Sometimes you've waited, I don't know, 2-3 days before starting this awesome remedy from grandma. So the question is, was the remedy effective, or did it just take that long for your body to naturally get rid of the cold? Think about going to the doctor. Sometimes you've waited days, and by the time you go, your body's already fighting it off. They prescribe you a medicine that may be effective in treating it, but your body is probably already on the mend. Sometimes we give credit where credit is not due. To prevent this, experiments must use a blind study, or the person receiving the independent variable does not know if they're getting it or the control. We do this a lot for medical purposes. We can give one person a drug where testing, and then the other person a pseudo treatment or placebo that we're not, like a sugar pill. When the person does not know if they're getting the treatment or not, we can determine how effective a treatment may be. A double-blind procedure is where neither the person receiving the independent variable or the research assistant who's taking the data knows which is the real drug and which is the placebo. And here's a little more about independent dependent variables. I'll let you read through it. Validity, yeah, you can read the definition yourself. Now, a good example of such research was done in Britain, where they found intelligence scores actually increased slightly from babies breastfeeding over bottle fed. In this experiment, the experimenters promoted breastfeeding, leading to more women breastfeeding their children. The control did not receive the promotion. When revisiting the children years later, the breastfed babies were 6 points higher on their IQ scores. Here's a graphic from your book to help with the different research methods. Now, we've looked at how experiments work, so let's look at how we use data in experiments and how to read them. Any good experiment, we must have descriptive statistics at the end of it. In order to do this, we can convert and use different forms of data. In this one is a bar graph, also called the histogram, which are really easily read. However, if we're not looking at them properly, they can be manipulated. For example, here's a histogram for brands of trucks, functioning after 10 years. Now, if I were to look at it briefly, I would say I'm going to stay away from brand Z and probably brand Y. Therefore, brand X, or the brand they're studying, looks really, really good. However, when shown the full scale of percentages, no brand really significantly outperforms the other, and the difference is so negligible that any brand is probably just fine. Here's a reminder of mean, median, and mode, and skewed distribution, which can be manipulative by having a few outlying scores, which can change your mean, median, and mode scores. Range is the gap between the lowest and highest scores. Also, take note of standard deviation. Standard deviation is a measure of how dispersed the data is in relation to the mean. Low standard deviation means data are clustered around the mean, and high standard deviation indicates data are more spread out. The bell-shaped curve is so typical we call it the normal curve. This often forms with large amounts of data, such as heights, weights, intelligence, and yes, even grades. You need to familiarize yourself with this curve. Inferential statistics help us determine if results can be generalized to a larger population. And the last big idea is statistical significance. We use statistical significance to determine how impactful our independent variable may be, or the claim that a result from data generated by testing or experimentation is likely to be attributed to the specific cause. A high degree of statistical significance indicates that an observed relationship is unlikely to be due to chance. To put it another way, when sample averages are reliable and when the differences between them is relatively large, we say the difference has statistical significance. Your book gives the example of when comparing intelligence test scores among hundreds of thousands of firstborn and later-born individuals, it indicates a highly significant tendency for the firstborn individuals to have higher average scores than their later-born siblings. But because the score is different by only 1 to 3 points, the difference has little practical importance. Now, can laboratory experiments illuminate everyday life? Well, yeah, we can find out a lot of things by doing experiments. However, There's lots of things that influence our behavior, such as gender, culture, prior experiences, and many, many other things. And then research. We do research, yes, on animals. However, there need to be safeguards. There need to be things that researchers do to ensure the safety of these animals. And does the impacts of the research impact humans for the better? And then ethics in human research. Obviously, anybody who's going through a research study needs to have informed consent of what they're studying and why. This can protect people from harm, but also gives them the information where they can make an educated decision on whether to go forth in the experiment. Confidentiality is very important. And then after the experiment, you must be debriefed so you knew what the experiment was actually about. That's it for now. Thanks for watching.